Hello, good afternoon, students. Yesterday, we had studied about isomerism in organic compounds. After this point, the next point in this chapter is to study types of cleavage of covalent bond. Before to study this types of cleavage or the types of breaking of bond, we will study what is a covalent bond. So it is one type of bond in which a bond formed by mutual sharing of electrons, meaning it's here this is hydrogen atom and the two electrons can be shown with the help of dot, and again there is one more hydrogen atom. So see that here is one hydrogen atom, and in between these two hydrogen atoms there are two dots. These two dots indicates the two electrons present between two hydrogen atoms. These two electrons are from these two hydrogen atoms, meaning is one electron from one hydrogen atom and other electron from other hydrogen atom. So these two electrons are shared by these two hydrogen atoms. That is a bond formed by mutual sharing of electrons, and that is called as a covalent bond. So here I will show this hydrogen single bond hydrogen. This single bond is made up of two electrons, and this bond is called as a covalent bond. In short, a covalent bond is made up of two electrons, and these two electrons are shared by these adjacent atoms. So these atoms are bonded together by a covalent bond. We had studied now what is a covalent bond. Now we will study the types of breaking of this covalent bond, and that is called as a bond fission. So we will study the types of cleavage of covalent bond. This cleavage meaning is breaking of bond, or it is also called as a fission of covalent bond. This fission of covalent bond take place by two ways. One of the way is a homolytic cleavage and other is heterolytic cleavage. First we will study homolytic cleavage. The name homo meaning it's same or the similar type of atoms. Just now we had studied the example of H2 molecule. So in the H2 molecule, two hydrogen atoms, they are similar atoms bonded together with the help of covalent bond. And the breaking of this bond take place in a homolytic way, that is also called as a homolysis. Meaning it's, see this arrow, this is called as a fish hook. So this curved arrow, half-headed curved arrow, or it is called as a fish hook. So here the one electron movement can be shown with the help of this type of fish hook arrow or this half-headed curved arrow. This indicates the movement of single electron. So just now I had explained to you that two hydrogen atoms. In between that, there are two electrons are present. They are mutually shared. Out of that, one electron goes with left side hydrogen, and that is the movement can be shown with the help of fish hook arrow. Similarly, at the same time, other electron present towards right side hydrogen, that goes to the right side hydrogen, and that can be shown with fish hook arrow. After homolysis, one electron is present on each hydrogen, and that is the odd number of electron present on hydrogen atom, and that product obtained, that is called as a free radical. So after homolysis of hydrogen molecule bond, a product obtained, that is called as a hydrogen free radical. Similarly, a breaking of bond take place with chlorine. I will show here. This is Cl atom. Then these are the two electrons present between chlorine atom, two chlorine atoms. So here these electrons movement can be shown with the help of curved arrow, fishhook arrow towards one chlorine and towards other chlorine. So product obtained after breaking of this bond is, this is Cl with one dot, that is a chlorine with a single electron, that is called as a chlorine free radical. So after breaking of this chlorine bond, we get chlorine free radicals similar to hydrogen free radical, and this can be defined, that is how chlorine bond breaking take place. So that is called as a homolytic fission, and this homolytic fission means the covalent bond is made up of two electrons that we had studied. So these two electrons goes one of the bonded atoms and other is bound to the other, means one electron goes with each atom, and this movement of single electron is represented with half-headed curved arrow, or that is called as a fish hook. The tail of curved arrow indicates the place from where the electron is removed, while the head of curved arrow indicates the place where the electron reaches at the result of movement. Such homolytic cleavage of covalent bond gives rise to two neutral species, and these two neutral species carrying one unpaired electron each. Unpaired means a single electron. So a species with single unpaired electron, it is called as a free radical. Sometimes it is just called as a radical. So free radical is a unstable, thereby a reactive species having the tendency to seek an electron from the pairing. The homolytic cleavage thus represented as I had explained to the example of hydrogen molecule, similarly chlorine molecule. Now here in our textbook, the example given as a AB molecule. So this AB molecule is bonded with single bond, and we know very well that a single bond is made up of two electrons. Out of these two electrons, one electron goes with A atom and other electron goes with B atom. That is shown with half-headed curved arrow, or that is called as a fish hook. So here A atom possesses one unpaired electron called as a free radical, and other product obtained that is called as a B free radical. So in this way, after breaking of AB bond, we get A free radical and B free radical. So in this way, after homolysis of AB bond, we get A free radical and B free radical. Here is one example of homolysis or homolytic fission is given. So this is a CH3 single bond Cl. This is a CH3Cl. Name is methyl chloride. Here is the single bond between carbon and chlorine. This bond breaks homolytically. The sign for identification of homolytic fission is half-headed curved arrow, or it is called as a fish hook. Here the two half-headed curved arrows are shown. One goes towards carbon and other towards chlorine. And we get here H3C radical, that is called as a methyl free radical, and other is Cl dot called as a chlorine free radical or chlorine atom with unpaired electron. So this is the example of homolytic fission. Here it is very important that this homolysis take place in the presence of catalyst, that is called as a symbol given for sunlight or UV light as a H nu. So this homolysis take place in the presence of sunlight or in the presence of ultraviolet light. So homolytic fission is favored in the presence of UV radiation or suitable peroxide or at high temperatures. So any one condition can be used for homolytic bond fission. The organic reactions which proceeds by homolytic fission are called free radical or non-polar reactions. So what are these free radical reactions or non-polar reactions? The organic reactions which take place or proceeds by homolytic fission, these are called as free radical reactions or polar reactions. Free radical have only transitory existence, meaning they have very short life. These are formed as a reaction intermediate which subsequently react with another radical or molecule to restore the stable bonding pair. A carbon free radical is sp2 hybridized and as a reveals the planar trigonal geometry. In this example, we had studied that methyl free radical. The structure of this methyl free radical with these orbitals is given. At the center, there is a carbon. This is a three-dimensional geometry shown on two dimension. It is one hydrogen with a normal line indicates bond in the same plane of carbon. Then this dark line or called as a wedge bond, that is the bond which is present above the plane, and a dotted line bonded hydrogen, that is called as a bond which is present below the plane of carbon. And these are the blue colored orbitals, that is called as a pz orbital, which contain unpaired electron, that is shown with half arrow pointing up. This is one unpaired electron present on carbon and which is present in the p orbital. And this is the structure of methyl free radical, shape of methyl free radical. Remember that this shape or the geometry of methyl free radical is a planar trigonal, and the type of hybridization is sp2 hybridization. Here the comparison between the stability between the alkyl free radicals is given. This methyl free radical is a CH3 dot, is an example of alkyl free radical. Here the four examples of alkyl free radical are shown. Here simply CH3 with single dot called as a methyl free radical. Similarly, here that is a mistake in the showing this ethyl free radical in our textbook. It should be CH3 CH2 instead of CH3 one CH3 there is a CH2 with dot. This is called as a ethyl free radical. Remember this formula well. It is CH3 single bond CH2 dot called as a ethyl free radical. Next example is CH3 single bond CH dot CH3. This is isopropyl free radical, also called as secondary propyl free radical. And one more example here, the central carbon in this radical is bonded with 3 CH3 groups and one radical or unpaired electron, it is present on the central carbon. Total there are 4 carbon atoms, and this alkyl group is named as a tertiary butyl. There is one unpaired electron on the central carbon, therefore it is called as a tertiary butyl free radical. So the order of stability of this alkyl free radicals is tertiary is more stable than secondary, than primary, than methyl free radical. Remember this order well. Tertiary is more stable than secondary, than primary, than methyl free radical. And that is about the homolytic bond fission. The second type of bond fission is heterolytic cleavage. The meaning of hetero is a different meaning is a bond formed between two different atoms, and the breaking of that bond is called as a heterolytic cleavage. Again, I will repeat the same thing. If the bond is present between two different atoms and the breaking of this bond, that is called as a heterolytic cleavage. In homolytic cleavage, we had studied that the breaking of bond between similar type of atom, here different type of atom, that is the main difference. Here the in heterolytic cleavage, again covalent bond, both shared electrons goes to one of the two bonded atoms. Here electrons are not equally distributed, not symmetrical distribution. It is an unsymmetrical distribution. Meaning is both electrons present between two atoms that goes to one of the bonded atom that possess negative charge and other possess positive charge. So after heterolysis, we get a negatively charged ion and other is positively charged ion. We know negatively charged ion is called as a anion and positively charged ion is called as a cation. So movement of this electron pair represented by curved arrow. Here the complete arrow is shown. In homolytic only single headed or that is called as a half curved arrow. Here the complete curved arrow is shown in heterolytic fission. Heterolytic cleavage of covalent bond gives rise to charged species, one with negative charge and other with positive charge. The negatively charged anionic species has more electronegative atom which has taken away the shared pair of electrons with it, and heterolytic cleavage is represented like this equation shown here. It is AB single covalent bond. Here the bond arrow is shown from the bond towards B atom. That indicates the B atom is more electronegative. It pulls the shared electron pair towards itself and forms a negative ion that is called as an anion. So B minus ion called as an anion is formed and A possesses positive charge. This is called as a cation. So remember again well that out of these A and B atoms, which is more electronegative, towards that both shared electrons pairs get attracted and that forms the negative ion called as an anion. Here is a one example again. Here the CH3Br is a methyl bromide. The bond breaking takes place between carbon and bromine. Here carbon is comparatively electropositive and bromine is comparatively electronegative. So both electrons of this bond, covalent bond, they goes towards the bromine atom which gives the bromide ion negatively charged, and CH3 positive that is called as a methyl carbocation. Here the bromine is more electronegative than carbon and therefore negative ion of bromine is formed that is called as a bromide ion. Now we had studied that homolysis take place in the presence of UV light or sunlight and that is represented with symbol H nu. But exactly opposite to this, heterolysis is favored in polar solvent. Polar solvent like water is very good example of polar solvent. Methyl bromide. In methyl bromide, bromine is more electronegative. The heterolysis of methyl bromide that gives the formation of methyl carbocation and bromide anion. A carbon atom having sextate, sextate means 6 electrons, sextate of electrons and positive charge is known as a carbocation, or it is also called as a carbonium ion. Carbocation is also called as a carbonium ion, which possesses 6 electrons around it, and it is highly unstable, very unstable, and therefore it is a reactive intermediate in many organic reactions. Here, similar to structure of this methyl free radical, this is the structure of methyl carbocation or methyl carbonium ion. Here the central carbon bonded with 3 hydrogen atoms. One hydrogen with normal bond. It is in the same plane of carbon The bond which is dark line or the wedge bond with hydrogen, it is above the plane than that of the carbon. And the bond which is shown with dotted line, that is bond present below the plane of hydrocarbon. So these blue colored orbitals, it is shown that is called as a p's head orbital of carbon, and a positive charge is present on the carbon, and here the 6 electrons are, that is one carbon hydrogen bond have 2 electrons. Here 3 carbon hydrogen bonds which possess total 6 electrons around carbon, and that is called as a sextet of electrons. We know if octet of electron is present, then it is a more stable, but here the sextet of electrons is present and therefore it is less stable. The geometry or the shape of this carbocation, it is again trigonal planar geometry. The type of hybridization is sp2 hybridization. In methyl free radical we had studied there, the type of hybridization is again sp2 hybridization. The geometry is also planar trigonal. Here again the same thing, hybridization, sp2 hybridization, and geometry is trigonal planar geometry. Only difference is that the pz orbital, atomic orbital, is a vacant and perpendicular to the plane containing 3 sigma bonds at the carbon. But in methyl methyl free radical, here the p orbital, pz orbital, contains one unpaired electron, that is not vacant, and that is the difference. Then the carbocations are classified as a primary carbocation, secondary carbocation, tertiary carbocation. They are denoted as 1-degree carbocation, 2-degree carbocation, 3-degree carbocation, and their stabilities are, it is similar to this free radicals. Tertiary more stable than secondary, more stable than primary, more stable than methyl. Same order of stability is observed here. This tertiary carbocation more stable than secondary, than primary, than methyl carbocation. Only difference here is this carbocation have positive charge and free radical have unpaired electron. That is the difference. Remember this order well. Again, I will repeat, the order of stability of carbocation is tertiary greater than, secondary greater than, primary greater than methyl carbocation. Heterolytic bond fission generates carbanion. The other species is called as a carbanion. So, which gets shared electron pair exactly opposite to carbocation. Other negatively charged carbon, that is called as a carbanion. Here is a one example. Here the single bond present between CH3 and Z. Here the Z is electropositive and therefore this electron pair, shared electron pair that goes to methyl group which possess negative charge. So CH3 negatively charged, it is called as a carbanion, and other is Z plus ion, that is a cation. So the central carbon atom of carbanium, that is completed with octet of electrons. Which are these octet of electrons or the 8 electrons around carbon? We know this negative charge means 2 electrons and 3 bonds around carbon with hydrogen. They have 2 electrons each. So 3 into 2, 6 electrons plus this electron pair due to negative charge. Total 8 electrons are present around carbanion. So carbanion is again unstable and reactive, and it is again intermediate in many reactions. This heterolytic bond fission or bond breaking take place in the presence of polar solvent, and the reaction taking place by heterolytic bond fission, these reactions are called as heteropolar or the polar or ionic reactions. Most of the organic reactions that take place in the solution, they follow ionic mechanism, and that is about the types of bond fission in organic molecules, homolysis and heterolysis. Thank you.